Okay, so for differentiability, I got an equation. For continuity, I got an equation. They both have A's and B's. They're both linear because there's no exponentials. So the last thing I got to do is solve for one of them, which will let me solve for the other one. Okay, so let me continue. Let me get some more room here. Okay, so the first one is A equals negative 20B plus 3. So A equals negative 20B plus 3. And then the other one is negative 5A minus 6 equals 50B minus 15. Okay, those are the two equations. To use elimination, we need A's and B's on the same side. But there's also another way to do it besides elimination, something called substitution. Substitution works if you have something already solved. So this guy right here, it's already solved for A. It's A equals. So what I can do is I can plug this guy everywhere I see an A. You can do that too, okay? Or you can do substitute or elimination like we did. Since I did elimination before, let me do substitution now. So substitution says A equals that stuff I just boxed in the red, negative 20B plus 3. So what I'm going to do for my other equation is everywhere I see an A, I'm going to plug in that value. Okay, so negative 5 parentheses, instead of A, I'm going to write negative 20B plus 3 minus 6 equals 50B minus 15. What happens when I do that is there's only B's, no more A's, because I've substituted them out. Okay, so distribute to get rid of the parentheses. So I get 100B minus 15 minus 6 equals 50B minus 15. 100B, combine like terms, I get minus 21, 50B minus 15. Subtract 15B from both sides, or 50B from both sides. 50B minus 21 equals negative 15. Okay, so let me move this guy over here. Solve for B. Add 21 to both sides. 50B equals 6. Divide both sides by 50. I get a fraction. 6 over 50, which reduces to 3/25. Okay. Once I get that, plug it back in for B. I would use the first equation since it's a lot easier, since it's already solved for A. Negative 20 times 3 over 25 plus 3. That becomes a 5. That becomes a negative 4. So I get negative 12/5 plus 3. 3 is 15/5. Add them together, and I get 3/5. Okay. So that's just another way. That's another way to solve it. When you're solving So systems of equations are just more than one equation that are linear. That's all they are. Okay, more than one equation that are linear. You have substitution and elimination. So I showed you examples of both. Okay, either one works. You could have done elimination just like we did on problem, the one right above. Like we did elimination here where we got A's and B's on the same side, added straight down, something went away. That works. Or you can use substitution too. Okay. Okay. All right. So let's go to example number 5. Example number 5. So I changed the question a little bit so you can match mine. Okay. Essentially, it says the same thing, but it was more of a delta math question, and delta math had like choices down there. So I just check continuity and differentiability at F. So is it continuous? Is it not continuous? Is it differentiable? Is it not differentiable? Is it both? Is it neither? That's what they want. Okay, so there's 4 options, at least probably 5 options. Differentiable, continuous, one or the other, neither, both. Okay, so the only difference here is we have a natural log. That's the only difference. That's the only difference between what we've been doing and what this is. But we found derivatives of natural log. We've done that before. So it's not anything different. It's just a different function. Okay, so continuity first. Okay, so continuity, the limit as x approaches 0 from the left has to be equal to the limit which is equal to the limit overall, which is equal to the answer at 0. That hasn't changed. Okay. So the top one I'm going to use for less than, for the negative side. So when I plug in 0, what do I get? What do I get? Sorry. All right, well, let's see. If I plug in 0, 2 times 0 is 0. So I get 3 times the natural log of 1 plus 1. What is the natural log of 1? What is this guy equal to? That's one of those things you should have memorized. You could, I mean, you don't need to have it memorized, but it's probably easier anytime you see this. Natural log, what's the natural log of 1? 0. Yeah, it's 0. It's 0. Every time. So what this is asking is what power of e gives me 1 as an answer? This is pretty much asking this. E to what power gives me 1 as an answer? 0. 0 power. So this guy is 0. So 3 times 0 is 0. Leaves 1. Mm-hmm. We get 1. Okay. Now plug in 0 to the bottom. Not as bad because it doesn't have a natural log. 0 times negative 6 is 0, plus 1 is positive 1 again. The overall limit, if those are both equal, then it's going to be 1. If I plug in 0, I'm going to plug it into the bottom one because that's where it's equal to. That's going to be 1. Okay, so what I want you to do now is check differentiability. We know it's continuous at 0. That's already said. But check differentiability now. I'll give you some time. Check differentiability, see what you get. So to find, first thing I have to do is find derivative. Well, the bottom function, the bottom piece is just going to be -6. The top piece, I have to find derivative of that guy. Well, we've done that before. This one isn't even that bad compared to the ones we've seen before. So the ones you've seen, some of the ones you've seen are a lot worse. So the derivative of 1 is just going to be 0. So we don't even worry about that, plus 1. So we have 3 times derivative of natural log says whatever is in the stuff you put on the bottom, and then the top is the derivative of that stuff, -2. Multiply 3 times -2, you get -6 over 1 minus 2x. That's the derivative. Okay, that's 4x being less than 0. Okay, so here I'm plugging in 0 to the top. So when I plug in 0 to the top, what do I get? I get 0 here, so that's going to be 1 minus 0, which is 1, so I get -6. Plug in 0 to the bottom. Well, I can't plug in 0 to the bottom because it's just -6. So that means it's -6, 0, -6. So this guy is both continuous and differentiable at x equals 0. So we're going to write that. F is differentiable and continuous at x equals 0. That's our explanation. We have our justification why we say that. Okay. All right. So now what I want you to do is number 6. I want you to try number 6 on your own. Try number 6 out. Okay. So that's the setup. Found the derivatives. Okay. So the top one, we got to plug in 1 to the original. So if I plug in 1 from the left side, I'm going to plug it in here. So I'm going to get -5. If I plug in 1 to the bottom, I get natural log of 1 again. Here I get natural log of 1, 0, times 2 is 0, minus 5 is -5. Plug in 1, and then, so both of those guys are equal. That means that guy has to be equal. And to get f of 1, I would just plug it into the bottom, which I've already done. So we know it's continuous. Differentiable. So plug in 1 to the top, I get 2. Now I'm over here. Plug in 1 to the bottom, I get 2 as well, which means I would get 2. And if I plug in 1, I would get 2 here. So they're differentiable and continuous at x equals 1. Okay? It's not always going to be the case. I know a lot of these are both, not always going to be the case where they're both. Sometimes it'll be continuous, but not differentiable. Remember, if it's differentiable, has to be continuous. Okay? Has to be continuous. And if it's not continuous, can't be differentiable. Okay? So sometimes what you can do is you can start here. If this checks out, you don't even have to check continuity because it's given. If it's differentiable, it has to be continuous. Or if you start here and you say that it doesn't work, then you don't have to check differentiable because it can't be. Okay? So that's one way to do it too. Okay? The last examples are just kind of repeats of what we've done. I just put some extra examples on there. So I'm not going to go over them. I think it'd be better spent time if you guys started on your assignment. So grab Desk Number Chromebook. It's on Google. It's on Delta Math.